So in the order it was given to you with substitution on top, slide it up a little bit so that you can see elimination. And then if you flip kind of to the back and just slide them both upwards or the applications one down, you should now have 3 words. Kind of line them up so that the sides are similar. So once you have these 3 words on the bottom, substitution, elimination, and applications, all you're going to do is fold all 3 pages forward so that graphing comes down on top of substitution. So once it looks like this, you're going to make 1 crease at the top and your book has been made, okay? So all we have to do is put 1 staple here. So if you hold it up, I'll come around and staple real quick. So we're going to do some of this together. Some of it I'm going to have you practice on your own. We're going to start by just folding up this top part here. You should put your name on it in case you lose it. You will definitely be able to use this on the quiz along with your 2 packets, right? So if you want to make note, 6-3 and 6-4 reinforce should be done. If not, get it done. The other thing, it didn't get stapled in there. I wonder if the other packet is the solving systems of equations. So these 3 things you can use on the quiz tomorrow to help you, right? They are meant to help you. All right. So what is a system of equations? This is something we've written a few times, but this is simply 2 or more linear equations with common variables. Two or more linear equations with common variables. So anytime there's 2 of the same unknowns, that's what that is, right? What are the types of solutions? So we might have 1 solution, right? This is in the form xy. And this is for intersecting lines. I don't really like how this is set up. So these have different what? Slopes algebraically. And graphically, obviously, I guess. So no solution we show that with 0 with a line through it. And this is parallel lines. So we talked about how parallel lines have same slopes, but different, I'm going to abbreviate different, y-intercepts, right? And then we also, our last one is our this pen is awful. I should have changed a while ago. It's hard to see. It's a little bit better. Our last type are infinite solutions. Remember, that is like our sideways 8. Figure 8. Infinite solutions, remember, are identical lines. So when we looked at this, I think it was in 6-4, we had the same slope and the same y-intercept. But I guess that's kind of obvious if they're the same line, right? Now put your phone away and please be quiet. So one solution looks like two lines that are intersecting, right? So we can just draw a line through here and maybe a line through here. And this solution right here would be xy. So these are created by the intersecting lines. Remember, no solution is when we have parallel lines, so we'll do this to the best of our abilities with the naked eye here. These are, I just said, parallel lines. Remember, we say 0 with a line through it for no solution. And then infinite solutions, I don't know, you can draw a line going through anything. But these would be identical lines. Created by identical lines. Alright. So those are the basics for what we've been doing for several weeks now. Hopefully that is good review. Today, I'm going to jump over the graphing section because, and you're welcome, you don't have to worry about it for the quiz tomorrow. You've already been tested on the graphing. If you need to retake the last quiz, this would be something to do and check with me on, along with, checking, correcting your quiz and retaking that. So that would be helpful for that. But we are going to jump to substitution. So your paper should look like this now. Remember, we are substituting one for the other. We have to have one solved for x or y. Here we have one solved for y, so we have to plug this in, this 2x minus 1 in for y. Remember this? It's been a bit. So we have 4x plus 3, and this is where we start our parentheses because we need to put in the entire expression 2x minus 11 into our new equation, and that equals negative 13, right? I'm just writing down that equation, but in place of y, we can put what y equals. If we knew what x equaled, we would put it in place of x, of course, right? So with substitution, we have to remember to distribute. So you can show that with your arrows, or you can write it over here. Distribute, right? So this becomes 4x plus 6x minus 33 is equal to still negative 13. Then remember, we have to simplify or combine like terms if needed. Here we end up with 10x minus 33 equals negative 13. And then we're just going to solve our equation for x, right? So our two-step, we have to add or subtract to get rid of our constant. So we're going to take the opposite of negative 33 by adding 33 to both sides. So I'm left with a 10x here. This makes it 0 and goes away. I bring down my equal sign. Negative 13 plus 33 is 20. Use your calculator if necessary. And then I have to divide by the coefficient of x to find 1x. The coefficient of x is 10, so I'm dividing both sides by 10, showing that with a fraction bar. So x, or 1x, is equal to 2. Now, remember, I have to put that in for x here. So I have to substitute what x equals in for x. So in place of that x, I'm putting a 2 and then minus 11 so that I can figure out what y equals. So here, y is equal to 4 minus 11. So y equals negative 7. So the answer to this is the point 2, negative 7. All right. What do I have to do before I can do substitution in number 6? Do I know what x or y equals yet? I've got to solve for x or y. Do you want to solve for x or for y? It doesn't matter. For x. So to do that, I would just be subtracting y from both sides, right? So I would end up with, I'm going to draw a little semicolon here. This is x is equal to that negative y plus 1. So now, in place of this x, I'm putting what x equals. So I'm going to start by writing my 5, and I'm putting in that expression, negative y plus 1, and then minus 9y is equal to negative 51. So again, same thing here, distribute. Negative 5y plus 5 minus 9y equals negative 51. Again, combine like terms. This is going to become negative 14y. Interesting. Plus 5 is equal to negative 51 still. And then we're solving. Doesn't look nice, does it? All right. So, if I subtract 5 from both sides, I have to get bigger, right? So this is negative 14y equals negative 56. So when I divide both sides by 14, negative 14 that is, should be 4. 56 divided by 14 is 4. So y is equal to 4. Negative divided by a negative is positive. Once I know what y equals, I'm going to plug it back in here to find x. So that means x is equal to the opposite of y, right? You can put 4 in parentheses if you want, but you know the opposite of it, plus 1. So y is equal to, I'm sorry, look what I did. X is equal to negative 3. You can go get a drink if you need to. Negative 3, 4 is going to be that solution. All right, so do you see how with substitution, a lot of it is distributing and combining? I wish we would have done one where they are equal to each other. Remember when we have to get rid of variables from one side or another, and that was mostly, this is just the first page of your solving systems of equations. Remember, when we set them equal to each other, we have to take the opposite of one of our variable terms to get rid of it from one side or the other, and then you can solve as usual. So that is the one that's a little bit different than these four, because I noticed they didn't give us two that were y equals. Here we can easily solve for x here, so I would probably add 4y to both sides, so that this becomes x equals 4y plus 5. And then remember, if I know what x is, I'm substituting for x. So I rewrite it as 7, and then put in that 4y plus 5. And then bring down the rest of the equation as is, minus 2y equals 35. So this becomes 28y. 7 times 5 is 35. Minus 2y equals 35. So again, we're still following these same steps. Distribute and then combine like terms. So we distributed, combining like terms. 28 minus 2 is 26y plus 35 equals 35. So what happens when we get rid of our constant? We see that y is going to be 0. So we have an x-intercept. So this becomes 26y equals 0. And we know that 0 divided by anything does equal 0. So if we were plugging 0 into this equation for x, I keep doing that, x is equal to 4 times 0 plus 5. So x equals 0 plus 5, which is just 5. So this x-intercept is 5, 0. And that's where those two lines meet. For number 8, it looks like it would be easiest to solve for y by subtracting 2x from both sides. So when I do that, semicolon, sorry, y is equal to negative 2x plus 9. So I'm putting that in for y. So 8x plus 4. And then in place of y, I'm putting what y equals, negative 2x plus 9. That way I only have one variable to solve for. So same process, distribute. We have 8x plus negative 8x actually, plus 36. What is going to happen here? These are going to cancel out, and we have 36 equals 36. So when true, and this is true, right? There is infinite solutions. If we got a statement, remember, that was not true, we would say no solution. You see how when we were simplifying, it got rid of our variable and we were left with number equals number? Okay, so elimination. Sometimes, like in this first one, we can simply add them up. When we notice we have equal and opposite of one or the other, we can add them up. So here, x plus x is 2x. y minus y goes away, which is what we want to happen. So this is equal to negative 12. So I would just solve for x by dividing by the coefficient of x. X equals negative 6. And then I would throw this in the top one. Negative 6 plus y equals negative 7. And then you've got a one-step equation, right? So I would add 6 to both sides. And y equals negative 1. So this would be the point negative 6, negative 1. Whew, they gave us a ton of these ones. Ten looks nice too. We have equal and opposite y's again. So if we add these up, we have 6x. The y terms go away and it equals 24. So we would throw this in here, divide by 6. X is equal to 4. So I'm going to plug that into the top. 4 plus 3y equals negative 2. So this one's a little bit harder than the last one because we have a two-step here, right? Am I in the glare over there? So if I subtract 4 from both sides, I end up getting 3y equals negative 6. So y has to equal negative 2. So this is the point for negative 2. So that one wasn't so bad either. Now, what happens? Suddenly it gets more difficult. We want equal and opposite. So if we had equal, we would have to subtract, right? And distribute a negative through one of them. Here, they're not equal either. But I think I could make my x's be the opposite of each other. What does the bottom x need to be if the top is 4x? Negative 4. So I would just distribute a negative 4 through here. So I'd probably just rewrite the top. 4x minus 3y equals negative 28. And then distribute. So negative 4x minus 20y u equals double u. 39 times 4. Oh, negative 4. So it's negative 156 triple u. All right, so my x variables go away. I'm left with negative, I'm adding these up, sorry. Negative 23y equals, so I'm actually combining these. So I'm going to go ahead and just add 28 to this. They're both negative. So negative 184. When I divide by the coefficient of y, any guesses? Divided by 23, like 8 maybe? Yep. Y is equal to 8. That was ugly. I would probably stick this into the bottom original because I notice I have x by itself, so it looks like it will be easiest. So x plus 5 times what y equals is equal to 39. We can do this. X plus 40 equals 39. So when I subtract 40 from both sides, I end up with x equals negative 1. All right. So I can't multiply 2 by a number to make it 7, but I could multiply the 3 by 3 to make it 9. So that's what I would do, distribute a 3 through here. So I would rewrite the top, 2x minus 9y equals negative 85. And then distribute that 3 through the bottom. So 21x plus 9y, that's what we wanted to happen, equals 39. So this becomes a 23x. My y term goes goodbye. And then I have a negative 85 and a positive 39. So if I said 39 minus 85, I have negative 46, which actually is nice because I can divide that by 23. So all that to say x is negative 2. My top looks the nicest, I guess, or not even. Actually, let's just go for the bottom. So 7 times negative 2 plus 3y equals 13. So I have to solve for y. It does become a two-step equation. Negative 14 plus 3y equals 13. Oh yeah, we could do this. So when I add 14 to both sides to get rid of that negative 14, I'm left with 3y equals 27. And that is divisible by 3, y equals 9. So this is the point negative 2, 9. Remember, it's always x and then y. Make sure you're putting them in the right positions, for sure. All right, we have a couple more here. And these, oh, the second. This 13 is of the challenging type. The 14 is not. So remember, the challenging type makes us multiply both equations to get them matching and opposite. The first thing I notice is that these are always already the opposite. That doesn't mean we have to go with finding a positive 21 and a negative 21. We could still make this 10x and a negative 10x. Any preference? We want to get rid of x or y? Y? All right, so I would make the top a 21x, y I mean. So that's, we're going to multiply it by 3. 3 times 7 is 21. Which means I have to multiply the bottom by 7 to get a negative 21 right. Remember, we want them to be matching but opposite. So first I'll distribute the 3. So I have 15x plus 21y equals 27. And then I would distribute this one through as well. 14x minus 21y, notice that's what we wanted to happen, equals 37 times 7. Negative 259. That's so gross. All right, so we're going to add these up. Adding them, since they're equal and opposite, we'll get rid of our y. So I have a 29x. My y term goes away. I'm going to subtract this because it's going to get less negative. I'm going to say minus 27 here. So this is a negative 232. And then when I divide both sides by 29, I'm hopeful that this works. And it does. X is equal to 8. That makes sense because 8 times 9 is 72. It ends in a 2. Oh, and then we got to plug this back into one of them. It doesn't really matter which. 2 times x, which is 2 times 8, minus 3y equals negative 37. Now that I see that negative 37, I'm like, oh, I should have done the other, but that's okay. 16 minus 3y is equal to negative 37. So I start by getting rid of my, subtracting to get rid of it. Subtract 16 from both sides. So negative 3y, this got more negative. So you can just put it in as negative 37 minus 16, and it will give you the answer. Negative 53. That seems awful. Did I do something wrong? I might have to go back and look. All right, so it won't go in evenly because I know these don't add up to a multiple of 3. So if I divide this by 3, I get 17 and 2/3. So I'm going to see what I did wrong. This is number 13. Oh, did I lose a negative somewhere? I did. So this should have been a negative 8. Nobody yelled at me. So this becomes a negative 8, and this becomes a negative 16. And look, I did actually want to add 16. So when I add 16, it actually becomes negative 37 plus 16. And it does give us a multiple of 3 as negative 21. So now we fix our error. And notice we knew we had an error, and you will know you have an error if something doesn't go in evenly. Y is equal to 7. So this is the point negative 8, 7. All right, it looks like, oh, this is a fun one. What happens if I match up my x's? I need this to be a negative 3, right? So this becomes negative 3x plus 12y equals 15. What do you see is going to happen here? If I copy down this other one, you'll really start to see it. When we get 1 to match, oh, I didn't do this. This should be 45. Negative 45. I didn't distribute all the way through. That's going to be the most common error. So all 3. So this is a negative 45, right? Negative 3x, positive 12y, negative 45. All right, so you are starting to see everything is equal and opposite on our variables. So we end up with 0, right, on the left is equal to negative 46. Does 0 equal negative 46? No, it does not. So when not true, remember we say no solution. All right, so then there are some applications. You will not worry about applications until next year. So hopefully, let's look at substitution method. I do want to go through one more in your solving systems of equations packet if you've got that handy. If not, you can just do this on a separate sheet of paper or follow along. Let's see. I was just wanting to look at a couple of these, maybe kind of going to the end of where you needed to do in hopes that maybe it would help you. So when you're doing substitution method and they're both solved for y, don't get confused. Remember, you're just putting what one y equals in for the other y. So it's going to be x plus 1. This is page 5. So this is just going to be x plus 1 equals negative 2x minus 23. So remember, when we have things like this, we have to get rid of one or the other by taking the opposite of it. So that should leave you with 3x plus 1 is equal to negative 23. And now you just have a 2-step, right? So this isn't one that we went over today, so I just wanted to be sure you knew what this looked like, or refreshed, because you should know, of course. But this becomes 3x equals negative 24. So x is going to equal negative 8. And then you would just put that in. So in the top one, y equals negative 8 plus 1. So y is equal to negative 7. So this would be the point negative 8, negative 7. Did I do it right? Did I screw anything up? Hopefully not. All right, so don't be afraid if you see like bigger numbers, maybe like number 12 here on page 5, where you're putting one and you're just setting these up equal to each other. So negative 4x plus 18 is equal to 5x minus 9. I always try and go positive, but you can do either way. So if I added 4x to both sides, it would stay positive. So 18 is equal to 9x minus 9. When I add 9 to both sides, 27 is equal to 9x. These are always going to be nice numbers. You shouldn't come up with fractions of any sort. So 3 is equal to x. So if I threw that back into, say, the bottom one, y is equal to 5 times that 3 minus 9. So y equals 15 minus 9, which is 6. So this is the point 3, 6. All right. So make sure you're getting all your boom cards and your pixel arts done. I think there was a boom card and a pixel art for substitution, a boom card and a pixel art for elimination. And then these two packets, 6-3, 6-4 reinforced packet, and then this solving systems of equations packet. Make sure those are complete. You got a little bit of time at the end of class today to be doing that. Review notes, make sure you have them for the quiz tomorrow. They're meant to help you. All this work we've done is meant to help you practice. So it's really important that you do those things, right? All right, that's all I got for you.